Hi everyone, this is Anirudh Reddy, Assistant Professor working in Electronics and Communication Engineering at BYT Narsapur campus, and I'm here to give a session on the course Digital Logic Design on the topic Sequence Circuits, both for SR NOR latch and SR NAND latch. So coming to sequence circuits, first of all we know the difference between combinational and sequence circuit. Suppose if you take a combinational circuit and if you take an sequential circuit. So in case of combinational circuit, so this will be your input and this will be your output, and this is your logic diagram. And in case of sequential, we have input and output, and the output is fed back again to the input of this. This is the input, this is the output, and this is some memory element. Think about it is a flip-flop or a latch. So if you come across a combination circuit, this output totally depends only on the input. But if you come across a sequence circuit, the output depends upon the input as well as the passed output. If you observe in the diagram over here, whatever the output we are going to get, so that is fed back to the again input to the circuit by using a memory element. So these memory element can be either a flip-flop or else a latch. So that is a basic difference between the combinational circuit and sequence circuit. So first of all, we will see what is that latch and what the different type of latches available here. So coming to the SR NAR latch. So latch is nothing but it is an memory element to store the data. Mainly it is one type of a memory element used to store the data. Either it can be 0 or else 1. So one latch can store only single bit of data. Suppose if you want to go with 4 bit of data, we need to go with the 4 latches. So based upon the type of number of bits of data we have, we need to go with the number of latches. So first of all, before going to that, we go with SR NOR latch. So this is the basic structure of the SR NOR latch, and this is the output states are Qn and its complemented one Qn bar. So before going to have the SR NOR latch description, first of all we'll have our NOR gate truth table. So suppose think that we have 0 0 0 1. If we have two inputs, the number of combinations are 4. So if it is 0 0, so if you come across OR, this will be 0 1 1 1, and suppose if it is NOR, it will be 1 0 0 0. So this is our truth table of NOR gate. Now here in case of this, R indicates reset and S indicates set. So in case of this SR NOR latch logic diagram, here this R indicates reset and S indicates set. So we will check for the different combinations of this S and R. So suppose think that if you take a scenario case 1. In case of case 1, suppose think that S value is equal to 0 and R value is equal to 1, and we check the Qn and Qn bar. So if you come across here when S value is equal to 0 and R value is equal to 1. Now as per the truth table of this, if you see, if any one of the input to the NOR gate is 1, the output will be automatically 0. So if you observe, suppose this is G1 and this is G2, we have one input to the G1 as 1. So if one of the input is 1 as per the truth table given below here, the output will be automatically 0. So then this 0 is passed across this, and if both the input as per the truth table of this NOR gate, and if it is 0 0, the output is equal to 1. So this Qn is 0 and this Qn bar is equal to 1. Now based upon the input we pass to this NOR gate, when S is equal to 0 and R is equal to 1, the Qn is 0 and Qn bar is 1. Now we'll remove this input and we'll see whether there is a change in the output or not. So in order to do that, we'll consider this both S and R values as zeros. So we'll consider this R value as equal to 0, nothing but we are removing the input, and we'll check whether there is any change in the data or not. So we have this input value as present data value, whatever the value we have, that is 0 0 0 is, so we are going to get 1, and this 1 is passed across this. 1 0 is nothing but what? 0. So we are going to get, when we remove this value, then Qn is 0 and the Qn bar is equal to 1. So for the case S is equal to 0 and R is equal to 1, we got Qn as 0 and Qn bar as 1. And once if you remove this value, so nothing but removing is nothing but we are passing the value S and R value as 0, 0. So we got this Qn and Qn bar as a 0, 1. So there is no change in the data here. So then we will assume the case 2, that is S is equal to 1 and R is equal to 1. Then we check for Qn and Qn bar. Now I am considering S value as 1 and R value as 0. Again, as per the truth table, we know if any one of the input to this gate is 1. So if you observe the gate 2, G2, one of the input is 1. So automatically Qn bar will be 0 and this 0 will be passed across this. Now one input is 0 and other input is 0. As per the truth table of this, when both are 0, 0, automatically it will be 1. So therefore Qn is 1 and Qn bar is equal to 0. Now for this scenario, saying we will do that, we will remove the inputs, nothing but then we will make that S value and R value is equal to 0. Then again we will check what is the value for Qn and Qn bar and we will check whether there is any change in the data or not. So what I am doing is just I am removing the value here. Now we have this 1. Why? Because the data it is already available. So that I am taking here 1, 0. 1, 0 is nothing but what I am going to get. It will be 0. Qn bar is equal to. Then that 0 is passed here. Then 0, 0. It will be 1. Again Qn bar. Now if you check for S is equal to 1 and R is equal to 0, we have Qn is equal to 1 and Qn bar as 0. And when I remove the input, that is S is equal to 0 and R is equal to 1, there is no change in the data. Whatever the data earlier we used to have, that we have across S. Now we will check whether the case for case 3, S is equal to 1 and R is equal to 1. And we check for Qn and Qn bar. So if you observe, these both the values are 1, 1. Okay. So if one of the input to either if you consider in case of this scenario, both G1 and G2 both for the both the gates we have one input as 1. So automatically these both the values are 0. So here we are going to get 0 and here we are going to get the 0. So if you observe, if Qn is equal to 0, Qn bar should be 1. But in case of this scenario, when S is equal to 1 and R is equal to 1, when Qn is equal to 0, we are getting Qn bar also 0, which is not correct. So that's why which is not correct. So we'll check while removing the inputs. So what happens when S is equal to 0 and R is equal to 0? We are removing the inputs and we'll see whether there is any change in the data or not. Now this 0 we got it, 0, 0 is nothing but we are going to get it as 1 and this 1 is passed across this, 0, 1 is nothing but we are going to get 0. Now in case of this scenario, Qn is equal to 0 and Qn bar is equal to 1. Now when S is equal to 1 and R is equal to 1, we got Qn and Qn bar as 0. But when S is equal to 0, while we remove the inputs, when S is equal to 0 and R is equal to 0, Qn is 0 and Qn bar is 1. So if you observe in case of case 3, there is a change in the data. Okay, so that's why this state we call it as invalid state. So by using this, we are going to write the truth table. So when S and R and coming to the state. So when 0, so if we have two inputs, so we are going to get 4 combinations 0, 0, 0, 1 and 1, 1. Okay. Now if you observe 0, 0, if you observe the 0, 0 state, so nothing but it is acting as what? Whatever the previous value we have, we are going to get that in the same state. So that's why this we will call it as a memory state. And when it is 0, 1, when S value is equal to 0 and R is equal to 1. So nothing but if you observe here, value what we have is 0, nothing but we will call it as reset state. And when 1 and 0, when S value is equal to 1 and R value is equal to 0, the present state, the next state what value you are going to get is 1. So now that's why we will call it as a set state. And when S is equal to 1, R is equal to 1. If you observe here in the different cases, we got Qn and Qn bar is equal to 0, and while we remove the inputs, then there is a change in the data. So that's why this state we will call it as invalid state. Okay. So if you come across SR NOR latch, when 0, 0 S and R values are 0, 0, it will be in the memory state, and if it is 0, 1, it is reset, and if it is 1, 0, it is set, and if it is 1, 1, it will be in the invalid state. So this is all about the SR NOR latch. And coming to SR NAND latch. So this is a basic logic diagram of SR NAND latch. So then again, if you want to proceed with the different cases, first of all we'll have the truth table of NAND gate. A, B and Z, 0, 0, 0, 1, 1, 0, 1, 1, and you know NAND gate is a complement of AND gate. So this will be ones and this will be zeros. This is the truth table for your NAND gate. Okay, now we'll go mainly with again whatever the procedure we have followed for SR NOR gate. Okay, so case 1 will go when S is equal to 0 and R is equal to 1. Then we check for Qn and Qn bar. So when S is equal to 0 and R is equal to 1. So if you observe the truth table of the NAND gate, if any one of the input is low, the output will be automatically high, isn't it? If you observe the first three scenarios, okay, if any one of the input is low here, the output is automatically high. So here one of the input is low, S value is low, so that's why the output will be 1 and this 1 will be passed across this, and if you observe here, if both the inputs are 1, 1, as per the truth table of NAND gate, we are going to get 0. So that's why it is 1 and it is 0. And coming to the removing the inputs, in case of SR NAND latch, it will be for 1, 1 and for SR NOR latch, it is 0, 0. So we'll check we'll remove the inputs and we'll check whether there is any change in the data or not. So that's why here in case of this, S and R is equal to 1, 1 and we'll check what is the value for Qn and what is the value for Qn bar. So that's why I am removing the inputs 1, 1. And if you observe here for the gate G2, both the inputs are 1, 1, so automatically it will be 0 and this 0 will be passed across this, and if it is 1, 0, we are going to get it is. So that's why it is 1 and this is 0. Now if you are removing the inputs for this SR NAND latch, nothing but making this S and R as 1, so there is no change in the data. Okay, so that's why it is acting as a memory state. Now we'll consider the case 3, case 2. S is equal to 1 and R is equal to 0 and we'll check for Qn and Qn bar. Now for S is equal to 1 and R is equal to 0. So you know if any one of the input is high, low, as per the truth table of NAND gate, the output will be automatically 1. So the Qn bar is equal to 1 and this 1 is passed across the input of the G1. If both are 1, 1 to G1, nothing but the gate 1 of the NAND gate, so output will be automatically low. So this we are going to get 0. Now we will see that we'll remove the inputs and we'll check whether there is any change in the data or not. So if it is 1 and if it is 1, so this is 0 and 0, 1 is nothing but as per the truth table of NAND gate, it is 1, and if you are passing this 1, 1, 1 is nothing but 0. So again you are going to get Qn as 0 and Qn bar as 1. So whatever the data we have earlier, same we got it when we removed the value. So that's why again it acts as a memory state. And now we will check for the case 3, when S is equal to 0 and R is equal to 1, 0. So we will check for the scenario when S is equal to 0. So S is 0, R is 0. And now we will check for Qn and Qn bar. So if any one of the input is 0 to the input of the NAND gate, output is 1. But in case of this scenario, both S and R values are 0, 0. So automatically Qn and Qn bar both are 1, 1, which is a not valid state. Why? Because if the Qn value is equal to 1, Qn bar should be 0. But in case of this scenario, both Qn and Qn bar are same, which is not valid. But we'll check by removing the inputs. So when S is equal to 1 and R is equal to 1, we'll check whether there is any change in the data or it is acting as a memory state or not. So this will be 1 and this will be 1. So if it is 1, 1 and the input is 1 here, so if it is 1, 1, it is 0. So this 0 passes across this, and if it is 1, 0, 1, 1, it is 0. and the 0. If it is 0, 1, it is 1. So here we are getting Qn as 1, Qn bar as 0. But if you observe this scenario, there is a change in the data. So that's why this state case, when S is equal to 0 and R is equal to 0, this is an invalid case. So therefore, as per the different scenarios, we will have the truth table for SR NAND latch. So S, R and state it is in. So 0, 0, 0, 1, 1, 0, 1, 1. If it is 0, 0, nothing but here it is invalid state. And if it is 0, 1, if it is 0, 1, what's happening? The Qn bar is 1. So nothing but it is set. And if it is 1, 0, Qn is 0. That's why it is nothing but reset. And if it is 1, 1, if you observe here, it acts as what? Memory state. It acts as memory state. So this is the truth table for SR NAND latch. Okay, when it is 0, 0, it is acting as what? Invalid state. And when it is 0, 1, it is 1. So that's why if it is 1, it is set state. And if it is 1, 0, it is reset. And if it is 1, 1, it is memory state. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.